Well, it is that time, so we'll go ahead and get started. Appreciate everybody joining us today for what should be our last Thursday webinar for the 2024 season. We'll talk a little bit at the end about what's going on in 2025 and how we could, maybe assist you in education and training and different opportunities like that. Today, we are going to do our second foray into residential construction, kind of taking a high-level overview of residential design and how it's impacted by the energy code. Again, hopefully you all know who we are. I don't see anybody from yesterday as from our recent the new I see a few new names, but maybe for those of you that don't know who we are, my name is Josh Harmon. I represent the Minnesota Energy Code Support Program, which is a educational program developed by the different utilities throughout the state to provide statewide support and education when it comes to enforcing the current Minnesota building code. We're looking at the commercial for the most part. Today, we're going to start our foray into the residential. And so if you ever have questions, feel free to reach out to us. If we can be an assistance to you either in your jurisdiction and you host some, in-person training or whatever that might be, just let us know. Always available, always interested in making that connection. One of the things that if you've watched any of our webinars, you participated, you know that it's a fundamental question for me, fundamental aspect of my code enforcement life has been this concept that if you understand the why behind a project, behind a code, behind an item, then you can better figure out the how it's supposed to be accomplished. And so when we think about why we have a residential code, obviously we understand that it's to provide that minimum safeguard for the occupants of residential buildings across the state when it comes to things, and it's based on these minimum expectations when it comes to things like means of egress, structural stability, and light, ventilation, energy conservation, protection against fire and other hazards. And so really what it's really looking to provide, again, a consistent baseline for construction across the entirety of the state. I understand it's enforced in different levels at different places based on the ability or the whether or not certain jurisdictions fall within enforcement apparatuses. But more importantly, this should be that standard that we should be confident that buildings are being built to again make sure that that we provide safe housing to people across the state in all areas. When we think about the relationship between the 2020 residential code and the energy provisions thereof in 1322, we understand that what that is it was adopted as really more of a 2012 version of the International Energy Conservation Code. And so that code, whether it was 2012, 2021, or 2024, is gonna really look at, how do we control things like heat loss, power utilized for illumination, and climate control, right? Make sure my computer's telling me you can't hear me. Can everybody hear me? Just give me a thumbs up if you can hear me. Okay. Stupid computers tell me what they think. Not always accurate. Thank you. So again, when we think about the energy conservation code, whether it's the old code, the new code, the future code, really what we're looking at is how do we properly and effectively utilize and conserve energy in our buildings. The code kind of drives into this concept of what is energy efficient, what is residential, and in that we know that there's both a definition that the state provides through the energy code, through the state. Let me get my laser. Through the state's adoption process, as well as what we see in the scope. A lot of the conversation we're going to have at the very beginning while we wait for the residential tag to complete its work and the residential energy code tag to complete its work is we're kind of bouncing around some of these ideas of what's out there. I don't see very many people that were on yesterday's residential tag. I don't know everybody that was on it. So again, if you have questions, feel free to reach out to us. And again, I think it's important that we maintain an awareness of what's in the codes, even in concept, as we wait for what is that next version of the residential code. But what we're talking about is those IRC1s, IRC2s, IR2C3s, those occupancies that include single family, multifamily, townhouses, and other structures that are, again, 3 stories or less above grade, right? And what the energy code does is whether, again, we're looking at, the IRC, again, addresses those detached 1-2 family dwellings and townhouses. Similarly, is what we're trying to really think about is how are we affecting residential in that perspective. One of the things that I think is important to understand as we transition, right, or as we consider transitioning to a new definition or a new code, is to look at the definitions, right? And so in the current definition, we talk about those single family dwelling units constructed in we talk about townhouses as those series of units that are connected or grouped in a single building, right? And so we're gonna treat each one of those as separate buildings again, and that's kind of what the code is kind of identifying for us. That is, again, mirrored in what we see in the 21 and in the 24 residential codes, because we start to identify the townhouse as the building that consists of townhouse units, each one being its own separate, right? So the state is kind of a little bit ahead of that, but it just is a little bit more clarified in the actual text of the code. So as a model, we kind of have an understanding of what is that, what is residential. When we think about it from the perspective of the energy code, looking at it as a model, we understand that the energy code applies within Minnesota to the residential building. But as we see it identified in further versions of the energy code, we start to, again, see that expansion of what is residential. Residential, it becomes this kind of thought of not only the IRC 1, 2s, 3s, and 4s, but also the group R2, R3, and R4 designations in the model code, right? So in the model code, that's what it's intending to address, is not just single family, multifamily, and townhouses, but it also goes into, maybe the dormitories, the small motels, the transitory places that are again part of that group R2, R3, or R4. And so if they're 3 stories and less above grade. When we have a mixed occupancy between residential and commercial, then obviously what the code says is residential provisions apply and commercial provisions apply to their respective areas. And so I was doing a project or doing a webinar just a little bit ago on multifamily that had the project we were looking at during this plan review session was multifamily housing with a retail space in one of the corners. And so we had to separate them. So we have the residential provisions apply to the multifamily, to the condos, and then the retail space follows the commercial, right? We understand that when it comes to energy conservation. When we look at, again, the code reminds us what are those our IRC 1, 2s, 3s, and 4s. And to kind of give us that idea of what's not within the context of the residential code when it comes to the construction components. When we think about it in the context of, again, the commercial energy code, we've talked about this before. When does that code not apply? Well, it does not apply in those single family, 2-family townhouses. And it also provides us this expectation of or recognition of what is residential, right? Again, if we're looking at multifamily buildings, what are residential? What are commercial? Because that is a model. We start thinking about that group R2s, right? We're looking at the hotels, motels, those timeshares, apartments. Part of the conversation, that sometimes gets brought up is, are we talking about where do Airbnb start to pull into this, right? Where do other types of accessory dwelling units start to pull in, right? We start talking about, is this residential, multifamily? Well, as long as it's under 3 stories, the energy code says it's all part of residential, right? Again, expand the group R3s that are identified in the code, as well as those group R4s. So we think we understand, we have an idea of when it applies, at least structurally. When does the energy code apply from a construct? We understand the use classification. Now we're looking at it from a construction perspective, and we see that the energy code applies to new residential buildings those additions, alterations, renovations, repairs, right? The changes in occupancy or use, right? So if we're transitioning from, let's say, an assembly use, and we've bought a building, we're turning it into residential, then again, it would need to comply. If we're changing the space conditioning, right? We start to think about taking that garage and turning it into a mother-in-law suite or an expanded bedroom or something like that. Now we're changing that conditioning. Then again, we need to think about how does the energy code apply? And again, like we talked about mixed occupancy before. So now we have this idea of when it applies and why it applies. Now let's talk about how it gets applied, right? When we look at what the energy code requires in 1322, we see the list of items, right? These are items that we should be somewhat familiar with. We talk about a lot in residential, commercial, and commercial energy code compliance, right? We're looking for those basic understanding of how the system is going to comply with those four pillars we generally talk about, right? The insulation, the mechanical, and the power, the lighting, right? And then the surface water heating systems that come in as part of that mechanical and surface water heating systems, right? When we look at the 2124, the major change we see from what currently exists in this particular section is the inclusion of, again, that energy compliance path, right? We want to know very forward, very upfront, which compliance path we're utilizing, because that's going to affect a lot of the evaluation that we do during plan review and inspection of flexibility within a project. One of the things that we also see identified is this building thermal envelope depiction, right? That's one of those concepts that's really to me, one of the more important things to identify, because again, it gives us that idea of what am I looking at within this structure to identify where that level of protection needs to be. When we look at in our previous webinars, we talk a lot, obviously we talk more about the commercial energy code. And so in that concept, we see the four basic components, and those are identified in specific chapters, right? We know this in chapter 5, chapter 6, chapter 7, chapter 8 and 9. And then within each of those chapters, they have mandatory, prescriptive, and alternative compliance paths specified for each of those different sections. When we look at both how the energy code the current energy code is organized, we see a very similar set of structural layout, right, or layout of the code. And so we see it identified as those general requirements, which is usually we're going to find some basic understanding of how we should install, what are those minimum expectations associated with certain type of features. But then we start really in chapter 4 to see it laid out as what is the building thermal envelope, what are those systems, both mechanical and surface water, and then what's that power and lighting considerations in our simulated performance alternative. So more so in residential, because I tend to alternate mechanical systems with air barriers, right? Air barriers are going to be that critical component in a residential that we don't always consider as much in commercial, although we know it's important to think about. When we start talking about when we see that laid out on that 1322 list of information to be provided on construction documents, again, we see it as insulation of both insulating materials, fenestrations, and ducts and pipes, as well as those mechanical systems, the lighting fixture schedule, and our air sealing details. So again, to me, those four things that we're kind of looking for: thermal resistance, air leakage, mechanical systems, lighting systems. So when we think about, again, what we're doing, if we were applying the residential code to a project, first thing we're going to obviously look for is, again, going to be that code addition. We know that they're going to reference the 2020 residential code, and by that, they're also going to reference the residential energy conservation code. One of those things that, again, we just hit on every time is going to be that identification of the compliance paths. We talked about compliance paths 2 weeks ago. Remember, when we see it in 401.2 of the current adoption, we see two alternatives. Well, the code tells us that we need to comply with all the mandatory provisions identified in the code. And then we need to determine, as far as compliance paths, whether we want to comply with the prescriptive sections or the performance alternative identified in section R405. If we go with the performance, we still have to do the mandatory items. And so what this has really, in a lot of ways, caused a level of confusion, let's just be honest, about what is mandatory in the code, right? And then that, depending on the level of engagement with your building departments or your builders, sometimes you get that, well, if it's not mandatory, doesn't need to be worried about. If we have a mandatory versus a voluntary part of the code, then it really starts to confuse people as to what's expected. So in future versions of the code, right, when we start to move into 18, the 20, more into 21 and 24, but especially in the 24, we start to see the term, that the physical quote unquote mandatory term that's identified in some of those sections that we see throughout the state's energy code. We see that replaced by a table, right, that goes with these specific energy compliance paths. So we still have the prescriptive compliance path in the 24. That's that methodology, that thought process that tell me what's in the code, I'll do it. Now it's everything in the code has to be complied with. Not here's some mandatory, here's some prescriptive. Nope, comply with everything you find, right? In section 405 or 402, 3, and 4, right? If we go to section 405, just like we see in the current code, in the model code, we see that simulated building performance method, right? That's going to be, again, comparing the design of the proposal against the design of a building built using a table that exists within the code. And so those two buildings will be simulated to operate for a full year and then compared based on a cost calculation, right? We're going to say it's going to cost me this much money to run this house as designed for 1 year. And then we're going to compare that against a similarly sized house following the model. We're looking for that relationship to say, does this building, how does it cost different? And it's going to take into account a variety of different things. We understand that the compliance path exists for that reason. The ERI, or the Energy Rating Index, is a lot of people call the HERS score. That's just a particular company that provides an energy rating index. That's, again, looking at the similar calculations that we see in the 405 simulated building performance method. But again, it's more of that performance, not money, that we're going to be evaluating. We're going to have a target number that we got to get on our performance rating schedule. So again, that's a little bit of how those compare. Well, here, I got extra slides to help. We talked a lot about this last week, but again, we're looking at, in the current code, you're looking at it has to be less than or equal to. In the model, remember, model. It starts to, in the 24, get into, it has to improve beyond the annual energy cost of the model, right? So if you're going to choose one of these simulated performances, then you're going to have to either be 80%, or if you're using fuel, or 85% if you're using all electric, right? And this got some calculations and additions for larger structures. Again, this is in the model. That's not necessarily to say it's what's going to be adopted, but it's just what's in the model. And so again, what we see in the 2012, you have the mandatory, and it says comply with all the mandatory components. So you have to read through the code and figure out which sections have the word mandatory next to it. In the 21 and 24, they create a table and say comply with this table, and as we saw there, comply with the table and meet these expectations when it comes to your energy performance, right? Again, a new concept is going to be the ERI. Again, there is no current ERI in the current code as it's adopted in Minnesota. If it was added, it would come in section 406. And again, these are the values. These are based on a scale, right? And so on a 100-point scale, what are we looking for? And these are the values, either with or without on-site renewable energy. And again, in the model, we don't know what the state's going to propose. But again, that's just kind of to give us an idea of how those compliance paths work. And based on those compliance paths, we again have that level of flexibility. When we think about, so understanding that, we have to ask, what are some of those design requirements? Well, we have to think about the thermal envelope, the mechanical system, and the power and lighting. Again, our concepts are important concepts. When we look at it from the current code, we see it identified as both the envelope, I tend to see it this way, and we've used this before. Again, a part of the reason why I use this consistently is because I want to show that energy code compliance, whether it's residential or commercial, really follows the same basic principles. Now we need to think about the envelope's location. We need to think about the types of insulation materials and designs. We need to think about fenestration controls and air leakage controls. Fenestration details and air leakage controls. That exists currently, right? When we read the current code, that's the way it exists. When we read our model codes in the 21 and the 24, that list really doesn't change of what those expectations are, right? The number, what we might be expecting to find in those pieces may change on one or two of them. But for the most part, the concepts that we're looking for are consistent. And so we want to know where that envelope location is, right? Because we want to know what is it on this in this project that I'm going to be looking at for my actual energy code compliance, my thermal envelope compliance. Before it was just, hey, is it insulated? I don't, is this the right place to insulate? I don't, do I know? Do I not know? Right? So that's why the code identifies the importance of the building thermal envelope depiction. Because now we can start to say, okay, this is part of that system. This is where we're expecting to see consistent air barriers, whereas you may have spaces that aren't part of the thermal envelope. Because again, we're not having conditioned spaces. We think about in commercial, we think about it in the context of semi-heated or unconditioned, right? And so we may have spaces that fall outside of it, outside of that thermal envelope. But we'll talk a little bit more when we think about it in some other contexts. But one of the things that the code, at least in the model codes, talks about is when we have like equipment rooms, fuel burning appliances, so again, a fuel burning furnace, a propane furnace or a gas furnace, whatever that might be, or other equipment. And those pieces of equipment are pulling outside air as part of that combustion, right? So we're having unconditioned air come through this supply duct or this air intake, and we're giving unconditioned air into this equipment room. Then we're going to make sure that our thermal envelope properly isolates that space, right? We don't want to have, again, if you were thinking about this, if this is my living room, right? It actually says gym, but if this is a living room and I've got unconditioned space coming in here and it's not properly sealed, then that air will move over, and then it's just going to affect the temperature that climate controls within this space, right? If I want this to be 70, but I'm bringing in 30-degree air, it's going to affect this occupancy, right? It's going to constantly cause more use than is probably necessary, right? So again, that's where it's important to understand what those expectations associated with the envelope, and so depicting that is one part of the battle. The other part is identifying what insulating materials are going to be used. Right? When we start thinking about insulation, we've talked about this before, but whether we're talking in the current code or in the model codes, what we're looking for in section 402 is an understanding of what is that insulation and what is it doing, right? Is it just an individual piece of material, or is it part of an assembly working together to resist heat transfer? Because we understand that insulation in and of itself resists heat transfer, but it doesn't completely stop airflow, right? So yes, you can slow the temperature of you can slow the movement, the loss of heat through a wall system, right, through a piece of insulation. But if I blow it hard enough, or if I have enough holes in that space, air, which is what is going to transmit through that system. And so there's a relationship that exists between the air barrier and the thermal and the insulating material to create this pocket or this protective layer around the conditioned space, right? We talked about it before. Insulation in and of itself doesn't use energy, right? It doesn't use electric. It doesn't use gas, right? What it does is it allows me to control what I've input in my house, right? I put my daughter on the bus every morning, and so she'll come to me at 8:05 and she'll say, "Daddy, it's time to go." Now her bus comes at 8:08. It's 3 minutes. It's like perfect clockwork. It's like it's perfect. And so at 8:05 we go upstairs, stand by the door, and she'll open the door to go out. Right? She has broken the thermal envelope. The thermal envelope exists, right? And I always have to say, Felicity, shut the door. We don't need to heat the outside, right? That's the concept that we see between the relationship of the thermal envelope and the air barrier. Regardless of how well that door may be insulated itself, when the assembly is broken and air moves through it, there's going to be heat loss, right? And those two values and those two concepts that we see in the energy code, again, apply in different ways. We see it as an R value, right, as that individual material's ability to resist heat transfer, and as a U factor, which is the assembly's ability to mitigate heat loss, right? Heat resistance, heat loss. And so we know that those are calculated, again, across an assembly if we're looking at the U factor. But we know that not all insulations are the same. And so, again, thinking about that in our application of those concepts within a design really helps us to have that flexibility, right? When we start thinking about, I want to use an R13. Well, to use an R13 bat in a wall cavity, I need to do some things. Or if I want to maybe only use 1 inch of insulating board, right? Then I need to replace those R values within the cavity to get to different U factors, right? I'm providing a level of flexibility there in what we're expecting to see. And when we look at that and when we apply that concept to buildings, what we're seeing is, again, in the current code, we're seeing, let's just use the wall as an example. We're seeing an R21 in the wall, right? We're seeing an R20 or 13 with 5 continuous, right? If we were going to apply this particular design to our climate zone 6, 13 plus 5, this is 3.5. It's not 5. It does not meet the requirements. However, if we were to do the math, if we were looking here at the U factor valuation for climate zone 6, we're looking for a 0.048, and this design is giving me a 0.057. It would pass. My maximum is 0.048. So no, it would not pass. Right? I'm getting my math wrong, right? But we can see where maybe adding some additional insulation in the cavity, going to that R17, would allow me to maintain just the simple 3.5 continuous on the exterior, right? So we start to have that conversation about, what we're trying to provide that flexibility, right? At least in my experience, a lot of times when I talk to contractors, and especially when we start thinking about where this table may go in the future, a lot of contractors will argue with me. I don't want to use 13 cavity. I want to use 13 and I want to be done with it. Well, then you're not looking for a prescriptive response. You're looking for something else, right? And so again, that's where we start to talk about it. When we compare the current code with the model code, which again, it's the model, not necessarily what's been adopted, or we can always have those conversations in those tags to discuss what's going to be adopted, right? But if we look at the 24 code, just as an example, in that climate zone 6, where we saw originally a wall value of 13 plus 5, we see the increase in the continuous insulation to 13 plus 10, or the 20 plus 5, right? What we're trying to do is protect and control more of the heat, more of the conditioned space within from escaping, right? We're trying to increase the resistance, the thermal resistance of our exterior wall, so that the individual providing that heating and cooling that particular space is, again, controlling more of that heat loss. We see, again, the reduction in, where's it at? Wood frame wall. Now you see it goes from 0.048 in the 2012, 0.048 in 2012 to 0.045, right? A 3/1000th of a difference, right? And so we're talking about a U factor wise, a very small change, whereas someone may say, well, that's a whole nother inch of or 2 inches of insulating board. Well, again, we might be focusing more on the U factor than we currently do on R values. Is kind of my point with this. If we think about where it goes in the future. Now we recognize it again. increasing insulation in and of itself does not directly affect electric bills, right? Because part of it's a relationship between insulation and the air barrier to protect the insulation, the space within inside, right? If I had, and I was looking at a picture of a door, right? If I had a 4 foot wide door, that would protect anything from exiting that door as far as air leakage, and my daughter opens the door and leaves it open for 5 minutes, it does no good, right? So we got to mitigate not just the insulation, but also the air barrier if we're going to be truly effective in controlling the environment within inside our buildings. Again, what the code tells us, whether it's in the 21, the 12, the 24, all of them, the current code or in the or potential for future codes, is that the code gives us instructions on how they think how insulation should be installed, both based on what the manufacturer's installations require, as well as what there's some specific insulation expectations, right? So what that's telling us is that if I'm looking at a piece of material, I need to know what's being installed. Now, 3 layers of thermal insulation, 2 inches thick, staggered overlapped, does not help me as much as I need to know what is the R value, right? Knowing you put three pieces of insulation doesn't demonstrate compliance. If I'm going to demonstrate code compliance, I need to have that table that says what we're looking at on that roof is either a collective R25, or more importantly, that each of those 2 inches represents 10 R values, right? So if I have 3 R value, 3 sets of 10, now I've got 30, right? So we need to have that level of specificity so that when my inspector is out on the field, he's not saying, oh yeah, they put down something. What was it? R5, R10, R12. Well, it was 3 pieces. That's all I know. They put down 3 pieces. Well, that's not going to support the project success. Let's just put it that way, right? And again, when we start to see codes identified, especially in residential, we see where it's per code in the specs, right? We're doing this per code in the specs. Well, you know what? Provide me the specified insulation value to demonstrate compliance with the residential code section 402.11, right? The current code tells me I need to know these R values. So if the current code tells me that I need to do this, then it should be an expectation. Code should not be something where I comply sometimes and not other times. If we have a complete understanding and expectation of compliance, then we better accomplish it, right? So per code is not going to work. I need to know what's that R value. When I look at the wall system, right, I see this here. This is telling me this is an optional R3 foundation insulation board at the perimeter, right? I see half a symbol. I don't even know if this is continuous insulation or bat insulation for the entire interior space. I don't know. So please provide the specific insulation R value for the assembly U factor for the below grade basement wall to demonstrate compliance, right? Again, I need to know that what you're putting on the plans is what's going to be built in the field. And if it becomes a guessing game, then that's not helpful for the design. Now, when we look at what that looks like in the future, again, the code starts to separate not just one value, but we start to see where we're talking about continuous versus cavity filled insulation in that below grade wall, right? That basement wall. So you might have and part of the reason we see that difference is again because of how it's designed. If I'm putting in a continuous insulation, it's continuous. If I'm putting a cavity, that cavity assumes that there's going to be a framing member that creates the cavity, right? So I have to calculate the impact of a 2x4 that only resists 4.5, degrees of heat through it versus an interior space which is going to, I'm filling with a cavity that's resisting a higher amount of R value, right? Each piece of lumber has an R value per inch, and so we're looking at it as an average weighted system. When we think about fenestrations in residential, I know this is one of those things that I personally always had to fight with until I got to the point where they realized I was always going to require it. And so instead of just providing me a simple table of all the windows that are going to be installed, right? We all have seen this, where we get the plan and it says that the king's house, the king's residence is going to be these windows, and this is the fixtures, right? This is the window schedule, right? I do not see in here where there is a U factor listed for how that's going to be part of it, right? There's no point of insulating this wall if both windows in this room are going to be missing, right? Or have absolute gaps coming of air coming through, right? So we want to provide, whether it's through a note or that does them by maybe zone or type, whether they're casement or fixed or operable, whatever they may be. Give me a U factor, or write down a general U factor maximum. So that again, when I go out in the field, I know what I'm looking for. I know what I'm expecting to see as an inspector. When I walk up and I see a window and I say, oh, it's a window. They put a window in. It matches the same size as the 3050 window. We're good. Or, it's whatever that window would be. I need to know what type of window I'm expecting to find. Sometimes you'll find it in a nice schedule like this. I blew it up so you can read it a little better, right? When this window and door notes, this says the U factor is going to be 0.32 and the solar heat gain is going to be 0.32. Now, the thing is, in my code, I'm not required, if we go back far enough, let me see if I go forward or go back. Let's go forward. Right? When I look at my current table, I'm not required to have a solar heat gain value. But in this design, they put one down. That may be because they're actually doing the math behind the mechanical system design, because the solar heat gain is going to allow it to accept in at least 32% of the sun's radiative energy into the space. So that's going to both heat during the summer, or heat that'll increase the heating capacity, the latent heating expectations, right? And so that'll impact how much I need to cool and how much I need to heat based on how much radiative heat is getting into my building through the window systems. Now, if it were me, just saying, if it were me and I had this plan and I approved this plan and I showed up and the windows were a 0.32 U factor and a 0.38 solar heat gain, I would make them call that contractor, call that designer to make sure that the equipment is going to be okay and properly sized, right? Even though my code says I don't have to have a solar heat gain, part of my approved plan says it's supposed to be there, right? And so I want to make sure this whole system works together. Sometimes you'll get that through a res check, right? They'll provide you a res check, very similar to a com check, that provides you those different values, right? What we're going to be, again, doing, or see how it passes, what we're going to be doing is we're going to be verifying that the value we see here matches with what we're seeing on the plans, right? Because again, every contract I've ever done, every inspection I've ever done, I have never seen a contractor standing on the project or standing at the site holding up their com check or res check, right? They've got their plans. And so the res check com check is not going to be something they're looking at. They're going to be looking at the plans. If the plans say I'm only putting in a 3.7, but the com check says I'm putting in a 0.24, I need to make that clear. I need a comment that says it appears to be an inconsistency between the proposed U factor identified in the com check and the res check and the proposed U factor on page A7, right? And again, we know what the code is expecting. Great point to put out there. That again, it may not be required by the table to demonstrate compliance, but it is required by the certificate. Good point, Nicholas, on that one. So again, we're going to want these values, and it's not that the value is hard to come by, right? When we start talking about these values are provided by the manufacturer. They know what these values are. It's just a question of adding it to the appropriate place on the document. Again, to me, it's one of those things I always think is important. So if we look at how the windows get affected, right, between the current and the model, again, I'm going to say it a million times, the model, right? We see that value went from a 0.32 for both climate zone 6 and 7 to a 0.28 and 6 and a 0.27 and 7, right? The skylight went down a little bit. But we saw it went from a 0.32 to a 0.28, right? And so we're expecting that window to, again, the same way we expect the wall to perform better, we expect that window to perform better when it comes to how it resists heat transfer. And again, This is when I'm on site and I'm verifying that this window is supposed to be a 0.24 on the east wall, and I show up and it says 0.38, 0.30. As an inspector, I can now say, hey, the window doesn't match, right? This isn't the right window. Call the architect, submit a revision, whatever we got to do, make sure that because again, this can affect the mechanical load, right? And again, I'm not going to sit there and do the math and say how much it's going to affect the mechanical load. I'm going to say it can, and that's why we have a code. You need to communicate with your designer and have him verify that this system still meets the requirements for that utilizing this type of window, or he can tell you to replace it. And again, remember, the client, the citizen in our community that is paying us for that window, and if they're being shortchanged, not by intention, but maybe by just reality, this one came in and they thought they could use it, then you're not protecting the public from that, right? The public is expecting, the owner's expecting that window to perform as it was proposed in their design, whether they understand all the nuts and bolts of it or not, right? The same way I expect that when I push the button in my car to turn the seat warmer on, I expect it to work. I don't need to understand why it doesn't work. I just need to expect that it does work. And the same concept when it comes to our buildings, right? And the same thing when it comes to air leakage, right? Within that envelope, we look at the location of the envelope, the insulation of the envelope, the fenestration that's within that envelope, and then the air leakage controls. Now, in the current code, we have that expectation of that 3 air changes per hour in climate zones 3 through 8, right? Sometimes what I like to always see on the plans is a recognition that testing is going to be done, right? That we all are of the same understanding that the maximum air leakage rate shall not exceed 0.30. Knowing there's a test coming, make sure that I prepare for it, right? If I know I have to pass this test and there's going to be somebody coming out who's going to independently verify, then I'm going to expect that a written report be provided, right? When we look at what the 24 code does, in the 24, now 23 it stays at 3, 21 it stays at 3, 24 it goes to 2.5 air changes per hour for climate zones 6 through 8, right? So again, we're seeing a decrease in the amount of leakage, right? Because what we're trying to do is control and manage all the condition space within inside that building, right? This is an example of a project where they not only wrote all this out, which again could be word for word from the code, they also provided all the insulation, air barrier installation table. Again, don't trust that someone's going to read it off the book. Put it on the plan. And in this project, that owner and that designer wanted to make sure that project knew what was expected when it came to how we install the air barrier in relation to the insulation so that we get an effective building, because they were looking for this particular project, not that you know about it, was a very high, was a large high-end home. And so they're expecting this building to operate the way it was designed. And that shouldn't be something that we say, well, only the wealthiest should be able to expect that their buildings perform effectively. That's the code. The code says that's a minimum expectation. Minimum expectation. You can exceed the 3 air changes per hour, or you can exceed the model 2.5 for the 24. But the minimum is that we allow for 3 air changes per hour of uncontrolled, and that's the thing that gets me, that's uncontrolled air loss, is 3 air changes per hour. Depending on the size of your home, we're not going to get into it, but the amount of air leakage that is ridiculous. The number of CFMs have lost air. Okay, when we start looking at residential requirements within the energy code, we see in the current code that, again, we have mandatory and we have prescriptive components that identify. Ultimately, whether we're looking at it from the 12 or the 21, we're looking again at that proper design, equipment efficiency, duct distribution, and system controls. We want to make sure that you've thought about the design, that the equipment meets the requirements for efficiency, and that we have an effective system for controlling when and where that mechanical system operates. Those same kind of concepts apply in the 24. again, when we're thinking about that mechanical design, we're not trusting Murray, my favorite mechanical installer, to tell me that based on his little cart here, this deserves a 1.5 ton unit. No. Again, the 12 tells me that I need to, the current code, current 2020 residential code, including its residential energy provisions, requires me to have a balanced mechanical ventilation system that is within 10% of the system's design capacity, right? And when we look at that, what that's telling us is that we also need to look at the climate design conditions, right? That it reflects. So that design, it's not hard. It's not asking for a lot to say. Make sure that this system accounts for the fact it's being placed in Monticello versus Duluth versus Rochester versus Ohio, right? Make sure that we've provided either the heating and cooling load calculations are based on the manual J, right? And that we've others, where does it say it in there? Other, what's it at? Accepted engineering practices, right? So you can use the handbook of fundamentals, the ASHRAE book of fundamentals. You can use the manual J. You could use some other system to demonstrate that you have evaluated the heating and cooling, the heating load, and that the equipment that you're placing in that building is sized to meet that load, right? And that you should not exceed, oversizing should not exceed 40% of the load calculation for heating and 15% for the cooling, right? Just because, a 1.5 ton will work does not mean it's okay to put in a 3 ton unit, right? What that's going to create is more inefficiency, and it's going to create equipment failure, right? So this is part of the current expectation of the energy code. And what it doesn't do is go away, right? The current energy code tells us that when we think about equipment sizing, that again, we base on the manual JS, based on the loads that came from the manual J or other approved heating and cooling calculation methodologies, right? So we're making sure this piece of equipment meets the requirements. Then there are federal regulations that regulate the efficiency of that equipment, right? In commercial, we've got the table. We've got our 20 tables to review. In residential, it says it just has to be the expectation of the federal law when it comes to the manufacture of these types of equipment. 9 times out of 10, it's been my experience that anything still around is probably going to have is going to meet those expectations. But again, we want to make sure that they meet the EPA requirements for efficiency. EPA and DOE. When we think about that duct system in and of itself, the code tells us that we have to think about insulation of those ducts, sealing of the ducts, and the prohibition of utilizing building cavities as part of that duct system, right? The table exists in 403.2.1 that tells us how thick that insulation needs to be. And guess what? When we look at it in the future, that doesn't really change much when it comes to the expectations associated with that duct system. When we look at mechanical systems in the current code, again, we have circulating controls and insulation for the prescriptive value, right? Again, we want to make sure that we're considering how we mitigate unintended or unnecessary reheating of storage tanks by controlling circulation in those hot water systems. When we look at the 21 and 24, again, we expand the way we identify the sections associated with those duct systems. But if we really think about it, we look at the prohibition regarding cavities, building cavities as part of the system, the requirement for sealing, right? But now we're have this expectation for the duct testing and air and duct leakage, because again, what's the point of having we sealed it? Then it should be again relatively simple to make sure that it's maintaining that pressure, right? If I had a balloon that every time I blew it up it popped, I would know that there's something wrong with that with the balloon, right? It goes further and explains to us that if it's what to do when that ductwork is located outside of the conditioned space versus inside the conditioned space, and then what it means to be buried within the ceiling insulation, because there was some confusion at one point about what buried meant, and thought, well, how is it in the ceiling if it's buried below ground? Two different concepts, right? So what it does is it just further expands our understanding If it's inside the conditioned space, we don't need to insulate, and our expectation of air leakage is less, or duct leakage is less, because it's within the conditioned space. It's, there's conversations that go on about whether or not that, that's a conversation for the day about what is within mean, right? If that duct is in the thermal envelope, is it within the conditioned space? No, right? It's in the envelope, not within. In versus within, right? It's an important difference. But again, those are considerations to think about when we start talking about the future. And maybe for those of you that are participating or have not already participated in either the residential tag or any of the tags that are currently going on. I was in two of them this week. Listening in, I would suggest that you participate if you get the opportunity. It's an important thing to be a part of those conversations moving forward in all areas of the code, not just energy code. When we talk about those controls, again, the old code reminded us we need a programmable thermostat, and that we needed to have a control that disabled supplemental heat when the cooling system was operating, basically, or that we were having, again, hot water circulating system controls implemented or as part of that system. That continues to be part of the code's expectations moving forward. The code in the current code identifies special equipment. I'm just going to highlight the swimming pools, the snow melt, and the PV systems. When we think about those in the energy code in the 24, at least for these two items, the snow melt and the pools, those continue to exist, and they don't change very much. We got a few minutes left to talk about power and lighting. Now, power and lighting is that thing, that's one of those areas of expansion in the model codes, right? In the current code, all we care about is fixture efficiency, right? Efficacy. 75% of the lamps have to be high efficacy bulbs, right? That's it. And then it also requires that if we have fuel gas lighting, that it doesn't have a continuously burning pilot light, right? That if you have one of these decorative features, or a light system that utilizes oil or some kind of fuel gas, that again, it's not constantly running when it's not being utilized. That translates over time into a lot of what, for those of us who do code, know as black bars, right? In the 21, you start to see a lot of the black bar change. In 24, that continues to move over. And now we've expanded from just going from how efficient is that fixture to now what kind of controls are we using? What kind of exterior lighting are we looking at? What kind of controls are we looking there? So again, this is model, not necessarily what's been adopted, but model just to think about. So when we think about that efficacy, we went from the current 75 to 90% in the 2018 to 100% in the 21 to now beyond 100. We have the specific lumen per watt calculation for those lamps in the 24, right? So it's just expanding the high efficacy component of the lighting fixture, right? That's what changes over time. We look at it from the interior controls. What we see start to happen in the 21, 24 is that habitable spaces have to have either a manual dimmer or an automatic control, right? I use my daughter as a perfect example. I've probably used it before. I'll use it again. For her 10th birthday, I bought her, I always got complained, always had people talk about the fact she leaves her light on. You can see it in the middle of the night when we're not home. And so I bought her for her 10th birthday a occupancy sensor for her room. And so it was the best birthday present I ever bought myself was for her. And so, it was a good hearted laugh for me. So she now has an occupancy sensor in her room. Guess what? It turns her light off when she's not in there, right? And when she's in there walking around and doing things or playing on her, sitting at her what is that thing called? Little desk, doing her makeup and talking to her friends, it doesn't turn off the light on her. When she sleeps, the light goes off, right? We've purchased the right equipment, it works effectively. What the code says in the future is make sure people have the ability to either dim them themselves or have an automatic sensor. I chose, and if it were me, if you could put a code in there that says for anybody under the age of 12, their bedroom must have an automatic shut-off control, I would support that code amendment. Just saying it. Just saying it. Personally, not as anybody else, just personally, 12-year-olds should anybody under the age of 12 should have an automatic control. It also identifies specific locations like garages or unfinished basements, laundry rooms, utility rooms, as places where we should have these automatic sensors as well. So that again, if we forgot to turn the light off in the garage, it doesn't stay on all night long. It shuts itself off. Again, energy conservation, energy consumption monitoring in a way. So what we'll see is again, we'll start to see those dimmer switches identified in our plans, right? We want to make sure the right controls are in the right places. It's not as problematic as we think. Exterior lighting, again, in the 21 and the 24, is really not for individual detached 1-2 family dwellings, right? So that's probably not our RRC 1s, 2s, and 3s, 4s, right? That's more for those group R3 building or those more residential multifamily, right? Those large scale multifamily. We're looking then at things like, facade lighting versus parking lighting, right? We start to differentiate. And what it really does is pushes us back to the commercial code. So if we've got a multifamily that's operating, multiple, this is a townhouse scenario. So you got a 2-car, 1-car, 2-car, you've got exterior lights. They have to operate on astrometric photo cells, right? For their downlights. If there's going to be exterior lighting, that has to be on its own special control, because again, it shouldn't be on all night just because I forgot. Now, my light control for my exterior light is inside the garage. So I'd have to, every night before I go to bed, I have to open the door to the garage, make sure the light's off, to make sure I don't leave my light on, right? That's not a requirement for residential. Traditional single-family structures, it's for when we do the large-scale multifamily. Same thing when it comes to parking lights, right? Parking lot controls and stuff like that. Photo cell controls to make sure that, again, we don't have parking lots at a large multifamily structure on all night, all day, when there's no need for lights, right? So again, just having those controls in place. Remember, 90% of what the codes in total are looking at are levels of control. How do I control energy consumption? How do I control thermal loss and heat loss? And if I paid to heat and cool this building, I want to control it. And if that means telling my kid to shut the door for 3 extra minutes, that means I have to turn that. If it means something structural, like, actually, and again, proper window installation, proper window, sealing and flashing and those kinds of considerations, then again, those should be something that's included in the plan and evaluated and verified by the building department. So what's missing in this conversation? Well, not much for the residential 12. In the 21, 24, we get into this. I'm just going to say it real quick. We get into additional efficiency packages, which again is a whole new ball of wax and a big conversation that I'm sure we'll be having a lot of conversations about in the future. It's a much deeper conversation than we can do in 2 minutes. And so I wasn't even going to try. But with that, I'm going to open it up to questions. If you have any questions, I'll try to be an answer. If not, I'll just keep going. If you have a question, throw it in the chat, raise your hand, put it in the Q&A. We'll do whatever we need to do. Remember, when you exit, you'll fill out a survey. I wanted to give you this heads up that we will not be having a normal Thursday webinar, CE Thursday webinar next week as part of the holiday Christmas season, right? No webinar. But we will be getting back together January the 2nd. And what we try to do, and I kind of broke this out a little bit for the beginning, we're going to try to create a series of opportunities where we're going to focus on plan review once a month. We're going to focus on inspections once a month. We're going to focus on codes, and then we're going to focus on something else. So that, again, we get a variety. We want to provide you a 6-part series on inspections, but we don't want to do it all at once. We want to be able to spread it out so your inspectors don't have to sit for that period. If you have any questions, feel free. Again, we're going to have to bring us your code questions on the 30th. If you have any questions, feel free to reach out to us to the helpline. If you're interested in participating in any of the in-person trainings or hosting of training, either for the region or for your specific department or community, please feel free to reach out to us. We're trying to really be a useful resource for you. I will see you at the AIVO. I will see you at Region 3. And again, we're going to be doing our normal MnDOT district by district traveling. But again, if there's something specific that you have questions, please let us know. If there are topics that you think are important that we need to make sure we address, please use those surveys so we can pay attention to that. And again, if you have any questions, feel free to reach out to Hope, myself, or Jim. For those of you that aren't aware, I think Hope was going to send an email. Jim Williamette has joined our team as a member of the member of our circuit rider team. For those that this current webinar series will end, and you will get a new link for 2025 that will be for the entire, for that period. So you will be getting a new link coming out sometime this week, if not next week. But there will be a new link. Say it again, new link. I'm going to go and update the website, send out the CEUs, and then verify that I don't have open CEUs. So this will be a fun period for me. That's why we're taking next week off. But you guys have a great Merry Christmas. Enjoy your your New Year's celebrations, and I will see you January the 2nd at 10:30. We're going to keep it at 10:30 for now. 10:30. So you guys have a great week. Be careful, and we will see you guys soon.